hangs overhead like a gloomy yellow cloud. Sealing the surface, it shrouds the light of the sun. It cuts off the underwater world from the air and life above. From the surface, we may hardly notice. We may see a patch of floating scum. Somewhere, there's been an oil spill. Somewhere, people are trying to clean it up. In the past, cleaning up spills was a dirty, difficult, and time-consuming job, and it still is, without proper equipment. Even when the visible marks have been erased, there are long-term effects on fish, birds, and other marine life. Many people, concerned at this violation of the environment, have banded together in all kinds of organizations pledged to curb pollution of our waterways. They see it as a threat to health, to recreation, to our future well-being. As part of the local community in many areas, the Navy is no exception in this effort. Some commands have responded with home builds, like this trash pickup boat. The Navy is coming forward with new equipment. This skimmer will simplify and speed up oil removal. It's one of the tools those who man the oil spill details need for fast and efficient cleanup. An oil spill can take place practically anywhere. Accidents happen on the high seas during refueling. They can happen at a naval facility 1,000 miles inland when an underground pipe begins to leak oil. And who knows why? Oil spills that occur on inland tidal waters are often the most serious. Areas such as this are ecologically sensitive, the birthplace of many marine animals and plants. And here is where many naval facilities are located. Every day throughout the Navy, huge quantities of fuel are transferred from tank to tank over miles of pipe. Your job may be routine and laborious, but it takes only one small slip to cause an oil spill. If you're not thinking, or thinking about something else, like your next weekend in town, accidents can happen. It could happen on a morning in port that is routine in every way, until somewhere in the maze of ship's piping, a valve is turned the wrong way. The amount of oil spilled may not be great. Most Navy spills are less than 50 gallons. But even a small spill calls for prompt action. This crew has been trained to make an immediate response, exactly as if they were answering the fire alarm. The base oil spill cleanup crew is notified while the ship moves to assure initial containment of the spill. They have the equipment they need to act quickly and effectively. The fire hose stream is used to nudge the spill down to where the boat crew can mop it up. Meanwhile, the cleanup crew is deploying their boom to ensure containment of any oil that gets by the ship's crew. Training, the right tools, and quick action have paid off. There are many different kinds of equipment to contain and remove oil spills, and many of them are being used in the Navy today. This newly developed skimmer is going into large-scale use. This one is home-built, one of a kind. But with any equipment you have, the operating principle should be the same. If it works, use it. Oil spill cleanup is a question that challenges the ingenuity of everyone at every level in the Navy. Spills differ greatly in type, extent, location, and weather conditions. The elusive oil slick is predictable in only one respect. Oil always floats on the surface of the water. Let's look at the natural forces that affect its behavior. Oil will move in the same direction and at the same speed as the current. Oil will move in the direction of the wind at about 3% of the wind's velocity. Waves can cause oil to splash over booms or sweep under them. Besides making work difficult, low temperatures increase the density of the oil. All these factors are operating simultaneously and must be taken into account in planning control of a spill. Often, however, you can use current and wind to your advantage. Equipment can be deployed so that winds and current drive the spill into the arms of the boom. When the ship's crew used the fire hose, they created an artificial current to drive the oil toward the pickup boat. The hose is never played directly on the slick. They're trying to keep the slick intact so the boat crew can mop it up. A 45-degree angle works best to generate the broad current that is needed. The crew had another tool, piston film, sorbitan monoleate. It works like a charm. This laboratory setup shows how. Piston film acts on surface tension, pushing the spill into concentrations that make it easier to pick up. At one end of the tray, a fan simulates the wind. Watch the effect piston film has when sprayed upwind of the slick. Piston film is making the task of cleaning up oil spills far easier. Still, it works best with thin oils, and its effect only lasts for a few hours. Some spills can only be contained by the physical barriers we call booms. Of the many types available, all can be used to limit the spread of the oil until it can be picked up. All are constructed along the same basic lines. A boom has some means of flotation to keep it at the correct position on the surface and to provide enough freeboard to resist waves splashing over the top. Next, there must be a skirt to keep the oil from being swept under the boom. Ballast weight is added to keep the skirt perpendicular. Finally, there is a strength member which runs the length of the boom. It must be strong enough to resist the forces of wind, waves, and current. The overall depth of the boom should be tailored to the wave and current conditions normally encountered in your area. Despite its advantages, there are always limits to how much can be accomplished with this kind of barrier. When waves are too high, oil will be washed over the top. If currents are too strong, oil will be swept underneath. A test tank demonstration shows that when a current at right angles to the boom is more than 7/10 of a knot, oil will build up in front of the boom and be swept under the skirt, no matter how deep the skirt may be. This effect can be avoided by placing the boom at an angle to the current, diverting the oil to an area of less current. Like any of the tools we have to work with, booms require maintenance. Cleaning after every deployment is essential. When booms are used intelligently and under the right conditions, they can be 100% effective in containing oil spills. Since quick deployment is essential, booms can be mounted on reels and positioned where they can be moved readily. They can be mounted on pallets and towed to the site of a spill. Any method of storage can be used that lets you act fast in an emergency. Securing the boom around the spill is only the first step. Now that the oil has been confined, the problem is how to remove it. Traditionally, oil spills have been cleaned up by spreading straw or other sorbents on the water, then picking up the oily debris. But this creates its own problems: disposal of the oil-soaked sorbents. With the advent of plastics, better sorbent materials have been sought. Polyurethane foam mats, available in the Navy supply system, offer many advantages. They float, they absorb a high percentage of oil, and they can be wrung out and used again. Today, these sorbent materials are most often used to clean up the final traces of a spill. To deal with a substantial oil spill, mechanical skimming devices of one kind or another are needed. Small weir-type skimmers are useful in cleaning up spills in congested areas around piers. The weir skimmer depends on gravity to drain the oil off the surface of the water. In water that is dead calm, the weir skimmer is very effective. This particular model has been adopted by the Navy for large-scale distribution, but several other types are serving satisfactorily at many naval installations. As wave height increases, the small weir skimmers lose effectiveness. Oil is lost as water washes over the mouth of the weir. Another variety, the floating suction skimmer, is compact and has very little draft. It can be used in shallow waters and confined areas, under piers and around seawalls. As the water surface becomes choppy, it too loses effectiveness. Another type is the sorbent surface skimmer. This skimmer uses a material to which oil can adhere, such as a metal disc or drum, or a fabric belt. For large-scale oil cleanup on inland waters, there is new equipment that operates on a different principle. This skimmer recovers oil and debris from slicks at rates as high as 200 gallons per minute. Collection is fast, efficient, and it is clean. At the skimmer's mouth is a rotating belt that forces oil and debris below the surface where it is collected. The recovered oil is virtually water-free. The rotating belt is the heart of the system. A test tack demonstration shows how it works. Wooden blocks are forced below the surface by the belt. Their buoyancy brings them up into the collection well behind. Oil, because it floats, behaves the same way, riding down the surface of the moving belt, then rising into the well. On board the new skimmer, the nearly pure collected oil is examined. Since collection takes place below the surface, wave effects are minimized. The new skimmer has worked effectively in 3-knot currents and in waves up to 4 feet high. Large spills in open areas require a major effort. Booms, skimmers, and support craft working together to form the cleanup team. A small spill may be dealt with by the efforts of 2 or 3 men. Small or large, spills demand quick action. To respond effectively, cleanup crews need the right tools and the training to use them. The effort we make is part of an effort many people are making for a cleaner and a brighter world.